Hi guys, so I'm here with your third lesson for algebra. I hope everybody's hanging in there. We have learned so far how to get these quadratic equations and graph them. We learned how to identify their turning point or the vertex, and we also learned how to identify the axis of symmetry, or that line that breaks up our graph into two equal pieces. And today we're going to continue to graph, but the difference is that today the equations or the functions are going to be given to you in the form of a word problem. And you want to make sure you pay attention to the instructions in the word problem, just because sometimes they might give you some important details that will tell you how much you actually have to graph. So it says in this example, Alex launched a ball into the air. For some classes, when we talked about this in class before, where I told you guys when you're throwing a ball into the air, right, the ball doesn't necessarily go straight in a horizontal line, right? When we throw a ball and you kick it, right, it goes up and then the ball comes right back down. Okay, so in this word problem, Alex took a ball and he kicked it into the air. The height of the ball can be represented by the equation h is equal to negative 8t squared plus 40t plus 5. That seems important, so I'm going to go ahead and annotate my word problem. I'm going to box something that seems important to me, where h is the height, so h is the height, and t is the time in seconds after the ball was launched. Graph the equation for t seconds. Okay, so let's see what we have here. So since I have my equation, then I'm going to go ahead and go to y equals on my calculator, whether you're using decimals or whether you're using the graphing calculator x84. And I'm going to put y equals negative 8x squared. Remember, you can use x instead of t, plus 40x plus 5 into my calculator. And then I'm going to go ahead and go to my table. So as you can see, we only have one quadrant over here. We don't have all four quadrants, which means we're not going to be graphing everything that's on our table. Okay, and as you can see, you notice that your graph also doesn't have any numbers. So the first thing that we want to do is actually go ahead and graph, and before we graph, we want to go ahead and scale our graph so that we know where we're plotting certain things. Okay, so I know that the input, what I'm inputting, my x values, here I'm not using x, I'm using t, which is in time. And usually we go in increments of 1 when we are labeling our axis with time. So here, for example, we start with 1, then 2, then 3, 4, 5, and 6. Okay, and you can keep going on, but you'll see that we're not going to need all of those numbers. This graph is actually long enough that if you actually want to skip a box, you can do that as well. I didn't do that here because I don't want to confuse anybody. Okay, now if I look at my y values, I can tell that I need to be able to graph numbers like 5, like 37, which is close to 40, and 53, which is close to like 55 or 50. So I think a good number that we can use here could be, we can either go up by 5s, you can go up by 2s, you can even go up by 3s if you wanted to. We are going to have to do a little bit of estimates here as we're graphing, because these are not all multiples of the same number. So I'm actually going to go up by 5, but I'm going to skip every other box. So this first line would be a 5, which means this is a 10. This would be a 15, which means this is a 20. This is 25, so this is 30. This is 35, so this is 40. This is 45, so this is 50. This is 55, so this is 60. And the only reason why I'm doing that, if you have enough space, you can write every single number down. The only reason why I'm doing this is because my pencil doesn't write too small, so I want to make sure that I have some space to figure out where everything goes. Okay, so now that I've numbered my graph, then I can go ahead and start plotting. So I have the point 0.05, so right here I'm gonna plot them in blue. Then I have the point 137, so I go to 1, and then I'm gonna go to 35, and then just a little bit above that. Oh, oops, that's not 1. Okay, sorry, so I had 0.5, I had 137, so a little bit above 35, 253, so 2, then I'm gonna go to 50, and I'm gonna put a little bit above 50. Then I had 353 right here. Then I have 437, so again a little bit above 35. And then I have 5, 5, so 5, 5 over here. Okay. Now some of you guys should be asking yourself, well, Miss, what's our turning point? What's our vertex? Why didn't we plot them? As you can see here on your table, our vertex, right, we see that our y values already start to repeat after 2. After 53, we go back to 53, then back to 37, then back to 5, but we don't see the number in between here. That happens when your vertex has a y value that's actually a next value, I'm sorry, that's actually a decimal, right? So your x value for your vertex is actually right between 2 and 3. So if you go to your graph between 2 and 3, then it's gonna be like right over here. Okay, so I can take my graph and I can connect all my points and bring it all the way down. Okay, you might be asking yourself, well, do we draw arrows? In this case, if we draw an arrow, that means that I can go into a negative height, right? If I draw anything to go down here, that means that I can go into a negative height, which doesn't make sense in the real world, right? If I throw the ball and the ball lands, the ball, unless it's like extremely heavy, it's not gonna go through the floor, so, or through the ground. So we stop right here after our 5. So now it says state the coordinates of the vertex and explain the meaning in the context of the problem. So again, your vertex is hard to see from this table here, only because it is going to be, the x value is a decimal, but I know that it's between 2 and 3. I know my x value is between 2 and 3. So the number that's exactly right in between 2 and 3 is 2.5. So I know that x is 2.5, right? If I go right here, right in between 2 and 3 is 2.5. And my y value at that point, you have two options. You can either try to estimate it from here, and I can see that's 55. Or you can actually go into you can actually go to the regular calculator and do -8 times 2.5 squared plus 40 times 2.5 plus 5, and see what that actually gives you. Okay, I'm going to do it on my calculator just to make sure that we all get the same thing. So what I'm doing in my calculator right now is I'm just putting in on the regular calculator -8 times 2.5 squared plus 40 times 2.5 plus 5, and that gives me 55, just like we estimated. So your vertex is 2.555. And now it's also asking you, well, what does that mean in the context of the problem? Well, if we're talking about the height and we're talking about time here, right? This is x, which is seconds, and y, which is the height. So this point means that after 2.5 seconds, okay, the ball reached a height of 55, okay, or anything doesn't have to, you don't have to necessarily use those exact same words, as long as what you wrote has the same meaning. And that's it. So on the rest of your tasks, just make sure that you're following the instructions that the word problem gives you. So if they tell you to graph just from one number to the other, that you only graph from there to there, and that you are not drawing arrows where it's not necessary in these word problems. Okay, just make sure you know how to identify your vertex and what does that vertex actually mean in terms of what you're looking at here.